Graphing Quadratic Functions. This is the page 2 of our notes. Parabolas have a geometric property called symmetry. That is, if the figure is folded in half, each half will match the other half exactly. The vertical line containing the fold line is called the axis of symmetry. The axis of symmetry contains the minimum or maximum point of the parabola, which is called the vertex. The formula for the axis of symmetry is x equals to negative b divided by 2a. Now, on the example, we will go ahead and find or solve for the axis of symmetry. We are given an equation which is y is equal to 2x squared plus 4x plus 1. It is important that you identify which one is the A, the B, and the C. Write down the formula for axis of symmetry. Then substitute. The answer is negative 1. Since the initial value or the A value is positive, then our parabola is opening upward, outwardly, and thus has a minimum point called vertex. Now that we have found the value of x, we can now find the value of y by substituting the x with negative 1 into our formula for the parabola, which is y is equal to ax squared plus bx plus c. In this case, we will use the given equation. Y is equal to 2x squared plus 4x plus 1. Now substitute the x with negative 1. Enter the expression in your calculator or Desmos online. The y value is negative 1. The vertex is at negative 1, negative 1. Let's do the exercises. Consider each equation. Determine whether the function has a maximum or minimum value. State the maximum or minimum value and the domain and range of the function. Find the equation of the axis of symmetry. Graph the function. Remember that if it's maximum point, then the parabola will be downward, outwardly. And if its minimum point or value for the vertex is minimum, then the parabola is opening upward, outwardly. Let's create a table and let's use some values for x, such as negative 1, 0, 1, 2, and 3. Now let's substitute each x value into the given equation on number 1. Copy the equation down. The first value for x is negative 1. So it's going to be negative 1 squared plus 3. The first value when x is negative 1, the value for y is 4. Keep substituting until you fill out all the values for y. Now that we have completed the table and we have x values and y values, we can now plot the points. Then connect the dots. Now if I quickly do the axis of symmetry formula, it will give me the x value, where I can already see what will be my x value here. There is no b on the equation, so it's a 0 on the top. The a is 1 and the x is 0. We can see on the table that this is the x and y value of our axis of symmetry, or the vertex, which is this dot here. Therefore, the axis of symmetry, the line is here right in the middle. Now, how are we going to find out the other dots? Go ahead, look at these two dots here. That is opposite to each other. They're both 1 square away from the axis of symmetry. And look at this dot. On the other side, we don't have a dot. But count how many squares this dot here is across or from the axis of symmetry. It's actually 2 squares. So you can tell that the other dot on the other side of this will be 2 squares away from the axis of symmetry as well. So you can place a dot here. Then connect or continue the parabola on the other side. Now there's a question of one of the released STAAR test, wherein you have to identify which ordered pair is on that parabola. So you're going to go ahead and do what we did and identify that x and y coordinate or ordered pair for this point here. And that's going to be -2 and the y will be +7. Now let's do the next example. I tried it earlier and I got set of numbers that are like extreme, and I can no longer plot it on this small quadrant. So what we're gonna do is change the values for x. We're gonna do something or use something that is much lower than -1. Okay? Let's try -2, -1, 0, 1, and 2. Let's plot the points. Now, what I would like to try is a value of x that is -3. So we'll have more points to the left side of this parabola. Then plot this point. We can see the maximum point and draw the axis of symmetry. Now that we've drawn the axis of symmetry from the vertex, which is the maximum, we can now see where we're going to plot the other points for the other side of this parabola. Let's look at these 2 points here on the top across each other. They're 1 square away from the axis of symmetry. So let's look at this next dot, okay, on the right side. There should be another dot on the left side, but let's count how many squares is this away from the symmetry. It's 2 squares away. So that means we have to count 2 squares from this symmetry. 1, 2. Therefore, we plot the other point here. Okay? Then you can connect and continue the parabola on the left side. Identify the x and y coordinate for that point. -4 for the x, -4 for the y. Now do the third exercise on your own. A golfer hit a golf from a tee box that is 6 yards above the ground. The graph shows the height in yards of the golf above the ground as a quadratic function of x. The horizontal distance in yards of the golf ball from the tee box. What is the domain of the function for this situation? You know that domain refers to the x value or x values. Look at your answer choices and cancel the ones that doesn't say x. Now you know the x value started on 0. So what is the highest x value we have? It's not the 110, but it all went up all the way to 230. Therefore, this is the one that is correct. 0 is less than or equal x, which is x is less than or equal to 230. What are the domain and range of g of x equals -1/4, parenthesis x minus 17, close parenthesis to the second power plus 61. Study your equation. This -1/4 is like the letter A, and it's negative. That means your parabola is opening downward. That will have a maximum of a number, which is the vertex. We also said earlier that all x values given an equation, quadratic equation, all x values will be all real numbers. Therefore, g, domain x is less than or equal to 17 is wrong. Now let's look at the range or y values. Since we have the maximum point, meaning everything else will be less than this, less than 61. Therefore, the answer is F, wherein all y values are less than or equal 61. And that makes sense over here. All the y values here will be less than that 61, okay, or equal to 61. What is the range of y is equal to negative x squared minus 2x plus 3? It is a negative a value, therefore it's opening downward with a maximum point here, which is the vertex. They're asking for the range y, so cancel the ones that doesn't talk about y. This is the max, therefore everything else will be lower than this point. So which one makes more sense? Will our y greater than 4 or less than 4? It should be less because everything else is less than the maximum, okay? Number 4, what is the domain of f of x is equal to 9 minus x squared? So they're talking about x. So we're going to go ahead and cancel this y and this one, which is talking about y. Didn't we say when we are given an equation, all the domain or x values will be what? All real numbers. Therefore, we have our answer. The graph of quadratic function f is shown on the grid. Which of this best represents the domain of f? Domain means x. So what did we say the values of x will be? Especially looking at your graph, it is continuously going to the left outwardly, continuously going to the right outwardly, meaning all x will be touched, whether that's positive or negative. Therefore, it's all real numbers. Number 6, which graph best represents a function with a range of all real numbers greater than or equal to negative 6? They want the values for range, which is the y values. So we're looking at the y-axis. There is a condition that says all real numbers greater than or equal to negative 6. So y is greater than or equal to negative 6. Let's look at the y. This negative 6 here, is this a y? That's the x value. While here, this is a negative 6. And everything else, all the points, will be greater than that negative 6. So all the y's will be greater or equal to that negative 6. Therefore, this is the graph that describes y is greater than or equal to negative 6. Number 7, the table shows ordered pairs that belong to quadratic function h. What is the range of h? So we're looking at the range, which is the h of x, the y values. I have a hint here that you can use a Desmos to enter the values and see the graph. But actually, by just looking at the values for your y, you can look at the least ones, the very least one, which is going to be the negative 8. Then read all the answer choices. Letter A says all real numbers. You can see that it's not going to be all real numbers for y. Because negative 8 is the smallest, therefore, you can see negative 7, positive ones. Therefore, it's not going lower than negative 8. So it's not all real numbers. It's not even B, all real numbers greater than or equal to 0. Letter C says all real numbers greater than or equal to negative 8. Is that true that everything else here is greater than negative 8? Yes. And it's also true that it could be equal to negative 8. Therefore, it's letter C. Number 8, which graph represents a function with a domain of all real numbers greater than or equal to negative 7 and less than 2? Looking at the graphs, they have restriction for the domain x because of those shaded circles or unshaded ones. Therefore, it's not continuously going on both sides. They said that x must be greater than or equal to negative 7. So it's true over here. Everything else to the right are greater than negative 7. So this is true. And what else is x? It should also be everything that is less than 2, but not equal to 2. That's why it's unshaded here. Therefore, this parabola represents the description of the domain. We can also write down this sentence that says a negative 7, which is the least number, is less than or equal to the x, wherein x is less than 2. Okay?